Remember the first great unit of the course defining a scientific background of environmental history. If you remember, environmental history focuses to the interaction between physical environment and society in the historical times. And this was the last slide about the basic concept of ecology, because we analyzed early environmentalist, geographer, historian, and this is almost the last great scientific school, ecologist. And in the 60s, in the 20th century, ecology became a global direction of thinking and take into global context each of discipline on the frame of ecology. Therefore was born environmental history, environmental sociology, environmental philosophy, environmental economics, and so on and so on. Therefore, ecology became a global thought, a global intellectual flow. One of the key concepts is the concept of ecosystem. We can describe, for example, the history according to frame of ecosystem, physical environment and human society. And in the last occasion, I spoke about a very interesting ecological approach to the history, flow of energy. How we can describe a human history according to flow and the pipes of energy in society and economy. Look at the next milestone. The next milestone is James Lovelock. On the 70s and 80s, he was very popular, very popular. He is a British scientist and studied basically astronomy and physical discipline. Physicist, he was a physicist. And received a contract with NASA. You know which is the NASA, American Space Organization, we can translate easily, and participate in the program of Mars. Mars, this is the planet, is a fourth planet in the Sun system, and the project at the turn of 60s and 70s focused there is and there is not life in the Mars. And which was the strategy? It was a large team, physicists, for example, anthropologists, mathematicians, and so on. So it's a great team. And finally, performed this project for 4 years, and the conclusion was no life, probably no life on the Mars. Why? Because on the time at the beginning of 70s, no sophisticated instruments for analyzing the conditions on the surface of Mars. The basic concept and the basic conclusion was each system which can see like with how the name is a telescope, is a classical or radio telescope, no dynamism on the surface of Mars. It's very steady, everything very steady. And one of the most important indicator of life, a dynamism, instability. In the stable system, no life. Very high proportion. Not final conclusion, but very high proportion. And very interesting, closed the project, and James Lovelock became a freelancer. You know which is the freelancer? No real job. No real job. Free intellectual. No freelancer. Which is that? No. You moved. Deny?
Yeah, no, I think it's a real job, but it doesn't include any company, but it's
yeah,
of course.
In intellectual context, sometimes it's may use.
You get money, so.
Yeah, get money. But basically, it's get money, but intellectual way of academical way, no job, no real academical and university background. And very important, change the direction of the question. Why? Because the question was, in the case of Mars, that why there is or there is not life on the Earth. Because the systems are very steady. And change and turn to the other side of the question and ask, there is or there is not life on the Earth. Obviously there is. But the question, the next question, second question, why there is life on the Earth? And made one of the most influential and one of the most seminal theory concerning ecosystem of the Earth, Gaia. Gaia, probably you know, name of the goddess, Greek goddess of Earth. And the theory basically focuses, this is the whole of the title of this book, Gaia, New Look at the Life of Earth, published 1979. No academic background, no university behind him, and he was a free intellectual, we can define. And which are the most important term and the concept and the most important conclusion of him. The first one, look at the definition. How define James Lovelock Gaia? Gaia, according to his definition, complex entity involving the Earth of biosphere. Atmosphere, ocean, this is the geographical spheres, as I show at the beginning of this course, ocean and soil. The totally constructing a feedback of cybernetic system which seeks an optimal physical and chemical environment for life on this planet. Therefore, define a whole of the ecosystem a self-sustainable system. Why interesting? Because from this turning point, turn two direction, the theory of Gaia. The first one became an intellectual theory and basically academical based theory. The second one, a theological direction of thinking, and they made somehow a similar pantheon of god and goddess like in the Greek mythology. And why define an ecosystem of Earth as self-sustainable system? Basically, a homeostatic feedback system, regular whole of the system of biosphere and the biosynosis and the biotope. The first argument of his theory, the global surface of temperature on the Earth remained constant despite the increase of energy provided by sun. Energy of sun increased from the beginning, from the freezing down the crust around the Earth with 25%. Increased with 25%. The solar energy, solar radiation. But the temperature more or less left the same. Why? Because probably you know the feedback system. Feedback. Nobody? What means the feedback? I show one example for that. For example, increase the solar radiation. Increase solar radiation. Sunbeam more intensively arrive to the surface of Earth. Increase the temperature. Increase the temperature. But majority of surface of Earth covered by water, ocean and fresh water. In consequence of raising of temperature, increase evaporation. Evaporation, you know which is the evaporation? Okay. Increase the evaporation. In consequence of increase of evaporation, increase the quantity of clouding. Therefore, the clouds reflect the solar radiation. Therefore, decrease the temperature. This is the stable feedback effect. Stabilize the system. Increase some impact, but the system stabilize. But look at one other feedback system. Decrease the unstability of system. Look at one other. For example, decrease the solar radiation, decrease the solar radiation, decrease the temperature in consequence of decrease of solar radiation. The next step, increase the surface of snow cover area and ice cover area. And probably you know the concept of albedo. Albedo it's a geographical concept, reflection of solar radiation back. Each surface there are a rate of albedo. How many percent reflect? And the white surface, much higher the rate of reflection. In consequence of that, increasing of albedo increase the speed of cooling. Therefore, destabilize the system. This is the one positive and the stabilizing, no, negative destabilizing and positive stabilizing feedback system. Both able change quality of weather and change climate system, stabilizing and destabilizing. And if we are looking first human of James Lovelock, changed a lot solar radiation, but greenhouse gases, you know which are the green, carbon dioxide, methane, sulfur dioxide, these are the greenhouse gases. And greenhouse gases able to trap the solar radiation, increase the temperature. And greenhouse gas is very useful. It's no enemies of humankind, because without greenhouse gases should to be a surface temperature minus 15 Celsius degree, without no greenhouse gases, minus 70. And before the Industrial Revolution, before the great production of greenhouse gases, the surface temperature calculated whole of the Earth, it's changed between 15 to 16 Celsius degree. Therefore, if we recall the differences between these data, the consequence of greenhouse gases activity is 30%. 30 Celsius degree. Okay. Global temperature, generally, it's stable. The second one, atmospheric composition, remain constant. Probably you know, probably you remember about your geographical studies, the most important gases of atmosphere. The first one, approximately 78% nitrogen, and the second one is an oxygen. It's 20.6%. Why so important? Because first of all, we have to define we are living in the third atmosphere of the history of Earth. The first one dominated vapor, the second one dominated by nitrogen, and after appearance of photosynthesis, increased the proportion of oxygen. But according to conclusion of James Lovelock, it's ideal proportion of oxygen. Why? Because if increase the proportion of oxygen above 25%, everything burn with spontaneous burning. No chance. For example, science fiction movie is very easy to destroy whole of the civilization. Aliens necessary to pushing oxygen to the atmosphere, and after the reaching this critical threshold, everything burned down. But it's very stable, very stable. And the last one, ocean salinity. Ocean salinity changed around. It's different according to condition of seas and oceans, but changed around 3.4%. 3.4%. Why so important? Because a high concentration of salinity in the water decrease each form of life. Look at, for example, Dead Sea. But not necessarily to travel to Near East, but in Transylvania, there are a salt lake, you know, Sovato. Near to the Sovato, it's a lake, Bear Lake, a very high concentration of salt water, and very strange, because if somebody walking into the water, not necessarily swimming in the water, it's enough floating like a cork. Therefore, it's, according to the conclusion of Lavrov, it's ideal proportion, because, say, the first form of the life appear on the depth of water, of the ocean. Why? Because without atmosphere, cosmic radiation, which destroy each form of the life, destroy on the surface the first appearance of life. But on the critical depth, which arrive the solar radiation, the light, and enough large for saving against cosmic radiation. This was the zone where appeared the first form of the life. These are the, but if somebody interested for the theory, the best option reading this book, of course, obviously, but these are the most important conclusion of him. It was very popular. This was the first wave of ecological thinking. But at the beginning of this course, I remember that I mentioned that environmental history founded in the United States. And for environmental thinking influenced formation of American civilization. Why so important? Because in the case of Europe, in the case of Mediterranean Sea, the civilization started in the Bronze Age, 4,000 or 6,000 years ago. Therefore, majority of civilization which formed in the Mediterranean area, it's a large Mediterranean area, it's started from modified physical environment. But the case of North American area basically different. When arrived the first generation of conquistador to northern part of Americas, basically it's a simplification a little bit, but cover whole of the North America forest from the east coast to the west coast. It's not totally, but mainly. And the transformation of physical environment connected very closely to the formation of the state. Not by chance, one of the most seminal books published about environmental history titled that Nature of Nation, because transformation of the nature connected to the formation of the nation. Because when arrived the first generation, it's covered by forest, and a lot of bison grazed everywhere in the central part of Northern America. And very interesting question. It's a first guest today, because it's very late and very depressive weather and dark and so on. So therefore, very important to communicate sometimes. My question: which European nation sent the highest number to United States? Later, American nation. Which nation sent the highest number immigrant to America? Northern America, of course. Later, United States. Which European nation? My guess, not Hungarian. Nothing to lose.
Spain.
No, not Spain.
Italy.
No, it's very interesting, because if we are watching a Godfather and classical Italian movies, it's the most important wave, like the introductory chapter of story of grandfather at the turn of the 19th and the 20th century. This is the great wave of emigration from Italy. No other? German. It's very surprising. Much higher the proportion of German immigrant compared with the English, Scottish, Irish. Much higher. But the next question, why don't speak recently German in United States? Because the first generation of immigrant in the 16th century, founder of Massachusetts, founder of first wave of immigrant, English. The second one, similarly. And the third one, therefore the basic institution formed by English immigrant. And the German immigration arrived to United States only quite late, at the end of 18th century. The first wave of American German immigration that to the British army recruited German mercenaries. And when the independence war lost by British Empire, the German soldier who recruited into the British army left. A lot of thousand soldiers left in the New World and tried to solve, find the manner of survival. And majority of German immigrants lost the language and assimilated, except religious communities. You can tell example for German religious communities. You know the Amish community, speaking North German dialect, even though, because the closed community saved against the assimilation. But if we reckoning the number of immigrants, the proportion of German much higher, but arrived later. And for example, the first wave at the end of 18th century, the second one in the middle of the 19th century, and when the following wave arrived, the former one assimilated. Therefore, no chance forming a German communities surviving the languages, except the religious community like Amish. Okay, look at the American school. Founder of American environmentalist Henry David Thoreau. It's probably I taught to you the concept of WASP, no?
Yeah.
Okay, we are over. He was a classical WASP. It's a white Anglo-Saxon Protestant. Graduated at the Harvard University. You know the story of Harvard University? Okay, we are over. No? It's I told to you 2 lectures before, and a very simple story, and good story that no great deeds and the small and the little deeds. Why? Because John Harvard was a very poor pastor. It's a Protestant pastor in the 17th century. I remember he died in 1637 or 35. He was quite young. It's a 32, 33 years old guy, and made a foundation and offered his library for foundation for supporting a high school. And some years later, other people took a testimony and left the fortune to the foundation. And the foundation, like avalanche, grow year by decade, by century, and finally, 4 centuries later, the Harvard University became top 10 university of the world. Recently, I remember, is the 3rd in the international scale of universities. Okay, He graduated at the Harvard University. Harvard University, obviously, on that time not so famous because America is very far compared with the European universities. It's a local university, quite prestigious in the local community, but it's quite a moderate international relation. And he graduated, and no job. It's a quite typical situation. I remember before the graduation, I remember I no chance for any job. It's quite a traumatic situation, and in this situation, no other way, finding some way out from this closed situation. For example, I tried to picking a fellowship to Western Europe, and I started my career in Switzerland. It's not the worst place, but for Henry David Thoreau, no chance for picking a chance for international fellowship. Therefore, he moved a mountain area alone, like a monk, and constructed a small hut and lived 4 years, no, not 3 years, no, 4 years, I remember good, 4 years between 45 to 47 alone in a forest area, a forest very far, Appalachian Mountain in east coast of United States, and lived alone and tried to integrate two traditions. The tradition of Protestant, a Puritan tradition, it's very moderate life, and integrate the Indian nature's cults, and somehow try to integrate. And he was a poet and wrote a lot of poems about the philosophical integration of Protestant heritage and Indian heritage. And very interesting that even though each American environmentalist, his career somehow start from works of Thoreau. It's very influential person in United States. Okay, the second one, I hope you remember the name of Roderick Nash. He is the godfather of environmental history. He applied first times the term of environmental history, and it's a quite funny boy. He defined, for example, a very short summary of American civilization. America contributed 3 things to the world civilization with the Coke, basketball, and national parks. And very interesting, it's possible because there is a generation gap between us, but during my childhood was quite a popular cartoon, a Yogi Bear, no? Macilaci, Hungarian version. Macilaci, Yogi Bear, stolen the baskets on the national parks. Why so interesting? Because we're thinking about the national parks, it's a closed area. A closed area saved each form of the life. But in the classical national parks, Yellowstone, for example, which was the first one. Somebody know which was the first protected territory in the United States? Central Park in New York. This is the first protected area. It's protected since the beginning of 19th century. I remember from 30s of the 19th century. Okay, but basically the national parks, the original American national parks, a picnic area with Indian rodeo, for example, and everybody walking and brought the picnic baskets and so and so. It's no a modern European national park like area. The first protected area, Auburn, Central Park. Central Park only second. It's very important. 61. Yosemite Valleys, and the first national park was a Yellowstone. Good. The key person of global formation of ecological thinking, Rachel Carson. It's possible, I told to you, that American academic mission writing text and communicate with the general reader. I spoke about yet, not? No, because in Europe, academic and university were quite a closed place. But in United States, from American Protestant tradition, there is a mission of proliferate the intellectual and academic and scientific knowledges for general reader. The simple person, general reader. And Rachel Carson wrote a lot of books for general reader. He was a marine biologist, basically, and wrote, it was a mission for him, for her, writing and communicate with the general reader. And the most seminal work of him, The Silent Spring, translated to Hungarian if somebody interested for. And why so seminal? Because he analyzed the consequence of influence of modern economy, modern agriculture to the physical environment. It was very important because after the Second World War produced the greatest economic growth whole of the human history. 3 decades from the closing years of Second World War continuously grew the global economy. No similar situation, never, before or after. But humankind had to pay very high price for it. Look at number of human population reached 1 billion American English or million in British English in 1820. 1 million in the closing year of Second World War, the human population reached 2.5 million. To the closing year of second millennia, reached 6 million, and somewhere, some years ago, or its estimation, it's reached 8 million. The great jump happened between these areas, from 2.5 to 6 million. And in this great jump and great increase, the living standards and the carrying capacity, everybody knows which is the carrying capacity, how many people are able to live in one territorial unit. Carrying capacity increased very quickly because in the modern agriculture applied pesticide and fertilizers. Everybody know which is the pesticide? Pesticiders. The most efficient pesticide was DDT. It's a chemical abbreviation. DDT. It's nuclear bomb of pesticide. If applied the DDT, kill everything, each insect. But why so dangerous applying of DDT? First, because may cancer on the body of human who apply the DDT. Secondly, if we are looking the chain of consummation, if we are taking out one brick from the one chain from the chain of consummation, whole of the chain of consummation broken down. If kill the insect, for some weeks die each small mammals, which diet based to the insect, and will die the predators, birds or larger mammals, and whole of biosphere will break down. And one day, therefore the title of Silent Spring, one day, it's forecast by Rachel Carson, open the window on springtime, and we are listening a deep silence. No noise, no noise. You remember what told by, what the name is, a British scholar, I suppose. James Hadlock, which is the peculiarity of life, dynamism, instability. But we made very stable the physical environment. And which is the final conclusion of Rachel Carson? We will destroy the biosphere, but because the humankind, there are a double nature, partly biological species and partly bearer of civilization, and will disappear with other animals and plants of biosphere. It's a very simple thing, very simple conclusion, but on the 60s it was a revolutionary conclusion. And Rachel Carson, the person who launched the great global ecological thinking. There's some data about verify the conclusion of Rachel Carson, how increase the pesticide, how increase the proportion of the pesticide, fertilizer. But there is a great dilemma, because if no apply any kind of the pesticide and the fertilizer, recently agriculture, it's mean today, not able to produce meal or food only for 6 million persons, 6 million human, and for 2 million, the modern agriculture able to produce food only with help of fertilizer. Without fertilizer, the speed of population growth not able, even the modern agriculture, serve with food. Okay, this is the day at the beginning of 70s bifurcated the environmental thinking. One direction into the direction of ecological policy and ecological policy and politics. You know which is the differences between the policy and the politics. Everybody know? Nobody know. Policy and politics. Policy is a practical. How we can, for example, organize the piping system and cleaning the water. It's a practical. Policy is the practice. And politics is a conceptual approach to the problem. This is the policy. Policy is a practical. Politics is a theoretical approach to the solving of political question. This is the policy and the politics. And the first milestone, appearance of Green Party in Western Germany, the Grüne. And this Green Party became the member of government first time in the 90s. One direction, other direction is academical, the way of academical and university researches and education, environmental researches. And each important discipline somehow made environmental or ecological branches. As I mentioned, ecological or environmental philosophy, ecological or environmental sociology, ecological or environmental economics, ecological or environmental. Every discipline made ecological branches. Good. If we are looking at a short survey about the ecological or environmental politics, the first is organizing the Fast of Earth Day. Organized first time at the United States, but 22nd April each year fast the Day of Earth. The second one, foundation and organizing of Greenpeace. Recently, this is the most influential international organization of environmental protection, founded by American member, but for legal reason in Canada, 1971. The second one, Club of Rome. Club of Rome. It's a very interesting organization at the dawn of formation of ecological thinking, and the idea based to the finding a compromise between leader of economic life and representatives of economic and university ecosystem. And generally, there are 100 members of Club of Rome. It's an institution. Half 50 businessmen and 50 scholars. And each second year publish a report about the condition of the world and the direction of possible direction of civilization. The most influential report of Club of Rome, published in the middle of 70s, this was the limits of growth. Limits of growth. And any other, mankind, the turning points was the title of the second report, but the first one, limits to growth. Okay? The next one, first international conference on the case of environmental problems, organized 1972 under direction of United Nations in Stockholm. And this was the first platform where organized and tried to organize the communication in the case of global warming, ozone layer problems, environmental monitoring and regulation. Important milestone in the 80s, Brundtland Commission. Gro Brundtland was a former Norwegian Prime Minister, and around him organized a team. It's, I remember, 67 person and one member, a Hungarian biologist, István Lang, and tried to somehow finding a compromise between the pressure of economic growth and environmental protection. And the conclusion of him, which introduced in the environmental communication, was sustainable growth, a sustainable development. Recently it's discussed, and a lot of scholars from the green and environmental side of protection try to deny it's not real, because probably you're listening a podcast about this problem of environmental protection. Recently it's very popular, even the circle of economists, the no growth economy, no growth strategy. But it's a debate. This is the question of debate. There is or there is not. Why? Because in a real environment, a biosphere, no growth, no sustainable continuous growth. Only in the body of human. How name the sustainable growth? Cancer. Because in the case of cancer, the cell not able to stop him or herself. Not able. It's grow. Unstoppable manner. Okay, sustainable growth. It's a key concept introduced by Brundtland Commission. The first international contract or agreement organized Rio de Janeiro, Brazil. And key problem of that was the biological diversity, scarcity of the water, and poisonous waste problem, and alternative source of energy. Why so important? Because if we are looking at the problem of modern society, partly we are in the very difficult situation because we are using a technology of the 19th century. Why? Because look at the combustive engine. You know which is the combustive engine? Okay, combustive engine. Gasoline or other version. And the electric engine. Invented both in the 19th century. Only in the 20th century invented only one new form of production of energy. Nuclear energy. And recently, if we compare, for example, a car, T model, you know, it's one of the first most successful model of Ford industry, and the BMW 5, no technological differences. Only the comfort, but no technology, the same. And recently, at the beginning of 20th century, the key problem that we are using according to level of invention, the technology of the 19th century. Same situation happened in the historical past. For example, it's possible, I told you a story that in London, even the 14th century, in the Middle Ages, had a smog. Smog, you know which is the smog? This is the abbreviation, it's a smoke fog. Smoke fog. Why? Because in the Middle Ages, for melting of iron, no, not melting, I remember that melting. It's a making iron.
Casting.
Casting.
Casting iron.
No. It's a. You know which is the charcoal? Charcoal. Okay. You know charcoal. Fascine. You know the cartoon Shushu the Dragon. How you can make a charcoal? Charcoal. The first step, hewing down the trees. Taking a trees in oven form is a closed form, and covering the trees with clay, and making only two small hole for burning and for smoke. And start, it's a profession, very one of the best paid profession of the Middle Ages. Very slow burning. Transform a tree, a fresh tree, to charcoal. And increase the energy of burning tenfold higher. And this is the plate of forest. Why? 10 unit tree necessary for 1 unit charcoal. Therefore, whole of the British Isles hewing down each tree which possible, because a metal industry not able to function without charcoal. Therefore, each of British, or not British, each of household in London using coal with very high content of sulfur, and efficiency of the oven in the household, it's very bad. Therefore, very low proportion of efficiency of the burning of coal inside of the oven, and with smoke, lot of floating material, it's a floating to the air of the city. And in consequence of very wet weather, it's an English like weather, the small pieces of humidity stopping in the small floating materials. And the fog, the smoke fog, so dense that describe the people in London walking into the Thames, the river. Because the distance of looking is zero. And it's a lung problems and infection and so and so. It's very problematic because no other way. If somebody would like to make iron devices, only charcoal, one way. Because the energy of coal much lower, energy of fresh tree much lower. And first step, destroy whole of the forest of England. After destruction of English forest, moved to Ireland. At the beginning of 17th century, in Ireland, which was a colony of England, had a large forest area. And hewed down. and the natural surface and the landscape of Ireland made by English metal industry. Disappeared the forest, well, small bushes and the huge grazing land. And to the 18th century arrived English metal industry. No forest even in England nor Ireland. What happened? Appeared a new invention. Making a cox, you know which is the cox. Coxing increased the energy, burning energy, concentrate somehow, of coal. Technological jump to the new level. And the other technological jump, for example, I hope we are before the technological jump. In the case of Industrial Revolution, before Industrial Revolution, how many energy, which kind of energy used by the contemporary government? Muscle of human. It was the 70% of energy, muscle of human, and 30% of energy, draw power of domesticated animal, cattle, horses, camels, and the simple engine, windmill and the water mill. No any other. But in consequence of Industrial Revolution, fossil fuels, coal and later oil and nuclear power activated, and from the engine list disappeared the human muscles. Jump over. And to my conclusion, recently at the beginning of 21st century, we are before the technological jump. Because we are using the same technology than at the turn of 19th and 20th century. Okay. The Kyoto Protocol, it's focused to the stabilization of greenhouse gases, and the last one I didn't made a slide about the Paris Agreement, which focuses to the stabilizing of global warming between the 1.5 to 2 Celsius degree, but very ridiculous the collaboration of state in this case, because on the first year of ruling years of Donald Trump, United States left the agreement and John Biden turned back, but practically the global warming is continuously unfolding. Okay, this is the environmental policy and politics. Somebody interested for environmental politics, I hope and I suppose there are courses in this topic. But look at the environmental history. Environmental history, first international organization, not by chance founded at the United States, American Society for Environmental History. If somebody interested for, this is the web address, and the European Society for Environmental History, founded a little bit later. I participated in this foundation. How we can define environmental history? Environmental history, one of the most seminal definition used and made by Donald Hughes. He applied 3 criteria. The first criteria, the culture and nature, it's continuum. It's a unit. It's a unit. If somebody would like to analyze according to point of view of environmental history, a historical event, have to agree it's a ecosystem with natural and physical part. The second one, methodology. It's very important because each discipline there are a very closed circle of methodology, because the rational criterion of rational thinking applying are accepted methods according to physics, mathematics, anthropology, geography, history, and other disciplines methods not applicable in other sciences. But in the case of environmental history, it's a quite liberal. Why? Because according to approach of Donald Hughes, environmental history not a real discipline, but it's a meeting place somehow. It's an interdisciplinary methodology defined because participate anthropologists, mathematicians, physicists, so and so. Therefore, no closed methodology. It's very open. And had to apply a sophisticated time and sophisticated geographical and space concept. Look at in the practice. If we are looking at methodology, three types of methods we can divide, we can separate. The first field evidences, the science, physical, chemical and biological evidences, documentary evidences, written and iconographic evidences, and archaeological evidences which located between these, because it's somebody participate in archaeological excavation, archaeological site, we can use, for example, chemical or physical methods and historical methods too. Okay, look at the first one. The first problem of environmental thinking was that a scholar, until the beginning of 70s in the 20th century, agreed that physical environment in the historical past never changed. The mountain was on the same place, the rivers and the plain area, it was the same. It's a stable background. The first step, formation of environmental history, denying the stable physical environment. The first one, which verified a fact of environmental change, a dendrochronology was. In the seasonal climate, the trees develop tree rings. In the tropical area, no, because in the tropical area there is only one season, a summertime. Therefore, no tree rings. But seasonal climate, it's a develop. Two parts are each tree ring. A white, yellow, it's a spring part of the tree ring, and the dark, it's a fall area, autumn area. But the size and the content of the tree rings contain information about the weather of the season. Therefore, if we reckoning the tree rings, we can judge first the age of tree, the second one, how changed the climate in the closed environment of tree. Andrew Ellicott Douglas was the first who applied the tree ring methodology, not necessarily hewing down whole of the trunk, it's enough drilling to the tree, and they made experiment from the tree, only one stick, and with help of the stick, the first some physical analysis, later in chemical analysis. And possible to make a floating trees chronology. For example, on this figure, you can see this is the alive tree, made a stick from the trunk of the tree, and made a sample from for example, some building. Very important to mention that, for example, in the Middle Ages, in France, constructed 10,000 cathedrals. 10,000 cathedrals, and the roof, of course, made by tree, and lot of buildings used by tree, and very easy to make. Easy, it's depend on the technology. Made a floating chronology because the tree rings structure, it's taking and covering with the trees which constructed to the building, and the other important reservoir of trees are peat bogs. Peat bogs, it's a marshland area. And in this manner, not so complicated, making a longer chronology. For example, in North Ireland there is a oak chronology. Oak, everybody know which is the oak? Is that species of tree, and Rhine Valley is a little bit longer. In the case of United States, fortunately there are a lot of pine, very long life, it's more 1,000 years, but no civilization for that. This is the weakness. Therefore, much more usable the tree ring chronology. But which is the interesting? Not so easy to see, but at the at the bottom of this slide there is a diagram how change the size of tree rings, how change the weather. And this was the first efficient evidence and conclusion which verified in the historical past the weather changed a lot of times, and the measure of the change, some period, it's quite high, other one moderate. The second crucial methods which verify the change of physical environment, isotope analysis, the oxygen isotope analysis. Oxygen in normal situation, there are in two forms of isotope. The stable isotope is a 16, and the unstable oxygen 18, and the proportion between the 16 and the 18 version 1 to 500. And the proportion of the 18 oxygen depend on the surface temperature. Therefore, oxygen 18, very sensible indicator of the change of temperature. And, for example, in the water or frozen water, in the ice, the content of oxygen, the proportion between two versions of oxygen, depend on the temperature. If drill, like here, a very deep glacier, continental glacier, ice cover, and making, like for example in the tree rings, a sample from the body of ice, able reconstruct, for example, the proportion of oxygen, the temperature, able reconstruct, you can see a bulb, small air bulbs. Why interesting? Because it's possible to reconstruct how changed the content of atmosphere, the gases of atmosphere. Moreover, on the ice sample, we can reconstruct a great volcano eruptions, because the small pieces of volcano eruption, it's falling down to the surface of glacier. Okay, and the temperature reconstruction show well that more 1,000 years how changed the temperature, verified with classical scientific methods that a climate and physical environment changed in the historical past. And some subversion of isotope analysis, the glacier. Somebody walked on the surface of glacier. It's an ice river. Not so far. It's enough travel to Austria or Switzerland or Scandinavia. It's very simple geographical process. Probably you remember from your university secondary school studies. On the mountain area, it's falling the snow. It's snowing. And melting and freezing, melting, freezing, cover and transform snow cover to ice cover. And in consequence of gravity, one of the most important force of the Earth, in consequence of the gravity, it's flowing down to the direction of the valleys. And the speed of flowing, it's 3, 5, 10 meters per week. It's quite slow. Why so important? Because in a mountain area, alpine area, one of the most important form of the animal husbandry, the cattle husbandry. You know, for example, the cattle, Milka, for chocolate. It's a cattle. Somebody work together with the cattle? No? I spent my childhood in a small village, therefore, because I would like to ask how many liters of water drinking a cattle by day. my guess today. How many liters of water one cattle, one cow? One hundred liter. It's huge. Therefore, it's a large animal. Therefore, moreover, produce some milk, and for transformation of milk, moreover, for walking up and down, necessary to drink. And for example, there is a herd with 100 cows, huge quantity of water necessary. On the high mountain, not so easy find a good place for drinking. Therefore, the glacier were the best place for drinking of a huge herd of alpine region. Therefore, the people who are living in alpine region very promptly know information about the position of the glacier, because the melting point of glacier was the drinking point for herds. And around the glacier constructed a stable for animals, hut for shepherd, and therefore a small village. And glacier, indicator of change of climate. On the time of humid and rainy period, increase, and cold period, increase the size, like a thermometer. Increase the size of glacier, and warm and dry period, retreat. Increase, retreat. Increase, retreat. And the shepherds and the employees of shepherd wrote down the position of glacier. Why? Because for cows, for herd, necessary to know which is the good place for drinking. Therefore, there is a glacier chronology from the alpine region, and show well how changed the position of glacier. How changed. And you can see, for example, this period named Little Ice Age. Little Ice Age didn't know that every time it's very cold, only changed the average of climate changes and the position of the glacier. And recently we are here, decrease and retreat every time the glacier. Probably you know the generally accepted view about the recent global warming, that recent global warming is a critical not for the size, because in the Holocene, somebody know which is the Holocene? Holocene, the recent geological age, started 11,000 years ago. And on the geological recent time had much warmer period. For example, in the middle warm Holocene, no glacier, never in Europe, much warmer. But the contemporaries, 10 or 8 or 4,000 years ago, neoglacial hunter, but lived in physical environment, ate everything, drank everything, and adapted to each possible situation. But recently, we are not able living like a neo-glacial hunter or hunter community, because we are a modern man, a modern woman, modern human. And about this situation, there is a theory of environmental history, a shark and the rat theory. You know which is the shark? This shark is living in the global ocean, and which is the rat? It's a rodent. It's a small rodent. If we are looking at human history, majority of the human history, until the Industrial Revolution, the human lived like a rat, adapt each situation, He ate everything and drank everything which possible. Until industrial revolution. But in consequence of modernization and forming in, artificial environment, Anthropocene, I spoke about this question, we survived only artificial environment. This strategy named a shark strategy, a shark. You know, I suppose you know that on the body of shark, no bones. Because appear before that evolution thought. The bones, whole of the body, cartilage. Everybody know which is the cartilage? Ports. Before the bones. Because the shark appeared, I remember, 300 million years ago. The contemporaries didn't survive. There is a lot of weakness of shark. For example, there is a tail, only one engine only. And if no swimming, not able to mobilize the water through the, I don't know which is the copper tube. Therefore, if a shark not able to move, it's choking. Because so so old construction. Because in the modern fishes able to move the water on the lung of the fish. But the shark is very simple construction. Able to survive only one form of the strategy. Very efficient. The shark is very efficient, but very fragile. Very fragile. And recently we constructed in the modern world a fragile, very efficient, but very fragile technical civilization, which based two pillars. Cheap water, cheap energy. Paying the bills, not so easy. But in the toilet, we are using drinking water. It's verified that the water is cheap, if we are using even the toilet. Okay, good. Some picture about how changed the position of its paintings about the changing of position of glacier, Warner Glacier. Okay, okay. We are over dendrochronology, oxygen isotopes, glacier, and the sediments. Sediments able indicate how changed the temperature and more sensible manner how changed the precipitation. Transported by river, wind, and glacier, place of accumulation, seas, ocean, and lakes. Here we can see the Rhone River. It's flowing into the Lake of Geneva, and you can see the color of river, like named the Tisa River. It's a blonde, it's a yellow, because very high the content of sediments. And this is the diagram about the size of the sediments, which indicate the quantity of precipitation, because higher precipitation increase and able to bring more sediments, lower one it's less. Very interesting indicator of climate change are rodents. This wall thermometer, constructed by a famous, unfortunately 2 years ago died, Laszlo Kordos, speleologist and geologist, and you know which is the speleologist. It's a scholar of caves. Cave, you know everything. Okay. For example, in Hungary, the most famous cave is Okterek. Somebody visited in Okterek or other caves? Not? I suggest to you because it's a very special place. For example, the deep dark, if somebody never visited in a cave, not able to judge, because on the surface some moderate light everywhere there are, but in the cave no light. Switch on the light, for example, even if somebody visit Okterek, because able to judge what means the dark, the real dark, real black dark situation. And I worked together with one of my friends who was a speleologist and visited some closed cave during my university studies and suggested to me, if lost the contact with other speleologists, sit down. Because half hour enough, losing the sense of orientation and sense of time, everything. Therefore, the best option in this case, losing the contact with other, sitting down and wait for escape. Okay, turn back. Cave is an ideal place, it's an excellent place, because if we are looking for civilization even on the time of Ice Age, because a cave functions like a building for human lodging, because if you go inside of the building, there is a cold point until this, for example, 20 meters from the entrance. This is the cold point which influence the change of outside weather. But after the cold point, the temperature of the cave the same than the average temperature whole of the region. Therefore, in Octalek, each season, inside of the cave, the temperature 9.5 Celsius degree. For example, this is the strategy of conservation of wine. Deep cave, no temperature changes. Deeper one, better one, in the case of wine production. And the human, therefore, made a lodging in the Stone Age, made a lodging inside of the cave because excellent temperature is steady and quite a safe place, only important to saving entrance or construct and find other entrances. And Kordos was a speleologist and visited a lot of times in the caves and realized that not only the human but even the birds nested inside of the cave, like an owl, night birds. And the digestion of the night birds, it's very sensible system of the stomach. Not able to digest bone, skin, and the hair. Inside of the courtyard, inside of the building, this building, living free night birds, free owl here. Therefore, there is a danger that you're walking, for example, at the dark inside of the court and bird night vomit falling to your shoes, for example. And the birds who started the hunting turn, after the hunting turn back to the nest and vomit the bones and the skins and the hair, and accumulating generation by generation, because inside of the cave no erosion, no wind erosion, no frozen erosion, nothing. Accumulate. And the rodents, the boars, the small mammals react very sensible manner to the climate change, wandering to other place, arrive a new species. Therefore, the construction of the sediments of bones and skins and hairs indicate the proportion between different rodents. And each species, there is and there was one ideal temperature. And combining different species able to calculate how change the temperature. And for example, this almost whole of the Holocene able to draw how change the climate, with help of Wall thermometer. Pollen analysis, it's a well-known form of the analysis. There are pollen tramps. Generally, it's a wet or marshland areas, and if drilling a sample to the bed of lake, like happened in Illinois, we can reconstruct how changed the vegetation. Starting with spruce and frondiferous forest appear. This is the closing period of Ice Age. It's the first is spruce, later frondiferous forest, ash and oak, and more later grass and rape and grass, general grass vegetation. The pollens able to indicate the warming, for example, in the case of closing periods of Ice Age. And finally, historical documentary sources. It's archival sources. It's man-made sources, individual narrative sources, anachronicals, memories, economic sources, newspapers, occasional prints, a lot of information. It's digitized recently, and digitizing help a lot for analyzing. And the institutional documentary sources, book of accounts, weather damages, printing, official letters, ship logbooks, and systematic meteorological information. And very efficient technology and the methods transformation of narrative sources to the time series. This is the scale of weighted indices if somebody interested for its peculiarity. For example, we accumulate huge quantity of documentary sources, and the information transformed to the indices: extremely cold, extremely dry, -3, normal, 0, and extremely warm and extremely wet. Why so interesting this method? Because able to make time series from narrative descriptive sources. Okay. Space and time. Space and time will be the topic of the following lecture. Okay, thanks a lot for your attention. It's not so easy because it's a methodological approach, but no chance for avoiding that, because we are starting to the scientific strategy of cognition, and necessarily define the terms, necessarily define the methods. And after the space and time, we will start the case studies. Okay.